So this is a new UPS I recently picked up, and yeah, my old one works fine, but I got this guy for a big reason. Everywhere I'm in, you get power billed depending on your time, and it goes from roughly 20 cents a kilowatt hour up to 45 to 50 for about 5 hours a day. I'm calculating it would basically save you money to run off of battery power during that time. You will chew up more power due to inefficiencies and stuff, but you would save money, which I find a bit odd, but does work. So I got this guy. It's 1500 VA, about 1050 watt. Online UPS. I got them used, pretty darn cheap. On the front we can see batteries. These batteries aren't very good. I can run a bit more tests, but they're pretty short right now. And they just pop out. I'm going to replace these guys with newer cells, and then I have to put external batteries in, which luckily this guy allows. This guy's also very heavy. It's roughly 50 pounds according to the spec sheet, and I believe it. So, okay. On the back, we also have a few more little goodies. It comes with a network card, even though I can't figure a way to get it to work, and it has a serial port, but I don't have the cable for it, so that's kind of useless. Power input port and some cooling vents. 6 power outs, which is going to just run to another rack mount power strip probably, or I guess 2 of them now. And then we have, in that little thing, I think there's a filter for, I want to say like networking or something, I'm not going to use it, I don't care. And then we have an emergency power off, so it's basically if you short those two, or I think if you disconnect them, it just kills all the power. So if you want a remote kill switch for everything in the rack. And this is the big guy. External battery split. So it needs 48 volt batteries, which is fun because my old one required 12, so I could just run a ton of 12 volt car batteries in parallel. That's what I've been doing. This guy here, you see these are small Anderson connectors. These guys are rated for 30 amps. So technically, 48 volts I can shove more than enough power. It's about 2.8 kilowatts max to those connectors, so that's going to be fine. And for a little bit more fun, let's just pop the hood off of this guy. Find out what all lays inside one of these machines. Screws off, so now it pops right out. Oh, that thing. That doesn't pop off easily. So now you can see the inside of it. And so here's a closer look at the circuit board. So here essentially you can see input power goes through here. Ton of filtering. I think under this piece looks to be an auxiliary power, probably for low power stuff. Maybe charging, probably not though. And just low power things like powering this little board's here sticking up. This daughter board is the electronics, so it does all the smart things. So it's what communicates with this network card and the little front panel board here. Here's the input filtering, goes through here. There's a bridge rectifier somewhere. These get converted to DC. And then the output, which converts up the voltage. And then the output transistors here, which converts it back to 60 Hertz. Goes down these wires to the output stuff. I'm not perfect when it comes to my power supply, so I don't know exactly what everything's doing, but that's a general synopsis. These are the output plugs here. We can see there's quite a few relays to switch between stuff, so it has a mode where it's just bypass. If you're overloading this, it will bypass all the power. So this is just mains power here. All the batteries sit up here, they're all plugged together. And right here you can see this more important thing, at least for my use, that's the back power connector which goes into right there from the back. And you can see that plugs into basically the same spot as that little connector right up there. Probably can't see it well. Is where the front batteries plug in. So this little cable goes around, the front batteries plug in there. So it's been a little bit of time since the last update, and really what all has happened is giant bank of batteries have now formed and moved here to use it. So now it's basically ready for install, and I can do a quick test just to kind of show you how stuff works right now. Yeah, I'll also do a quick output test and show you what the output looks like, and then we're gonna go put them in the rack here. So here's the full setup. So multimeter here, this is the UPS, and then giant bank of batteries. So multimeter is running. We could see the total battery bank voltage is roughly 51.5 volts. I've tested all of these. They're relatively equal within about 0.2 volts, which is good. And essentially in order to power it up, so this is the back connector on it that allows you to run DC in from external batteries. And I just got those connectors for these guys here. Just match the colors. And they plug right in. And you do have to have batteries installed for this UPS to work, as I showed in the last video, because that was annoying. Plug in, UPS just flicked on. It's now running. It's going to slowly charge these batteries, but since these are full, it's not really going to charge them. And then it's going to pump output power out of it once this guy is turned on. It should be turned on right now. Here I am using a frequency counter, and you can see it's basically spot on. If I do anything to try to knock it off, like unplug it, it will be spot on like I tested it. This is more accurate than wall power, which is normally within 1% or 2% depending on the time. And here's the voltage output, so we're looking at about 120.8 volts on the output. And if I go crank this heater to on mode, it drops by half a volt for a little bit. I drank it, so I'm pulling way too much power. It's still within, didn't really go out of spec by more than about half a volt during the whole thing. And if I unplug it from the wall, it goes up a little bit when it changes stuff probably. I don't know. And then if I plug it back in, there's never a voltage drop, and I'm pulling about 1,000 watts from it right now. So if I completely turn this off, it jumps up and then it jumps back down. So it does do a little bit of variance to try to compensate, just because of if you're pulling a ton of power, it's used to providing power, then it's providing it and you're pulling nothing for a little bit of time. Let's go look at the scope now. This is a CRT scope, so it's going to look pretty darn bad on video, but this is kind of the thing. You can tell waveform really looks fine for what it is, so there's no real errors or anything in it. And then if I go to, let's say, flick it off, you can see it kind of does nudge it around a little bit, but it cracks for it, and there's no major obvious changes. And if I unplug it from the wall, you notice that it has a little bit of a drop off for a little bit of time, but realistically is mostly spot on because it is a online UPS, unlike the other ones, which I think I showed earlier, or you can see pictures of online, where it completely changes the waveform and skips a cycle whenever you're whenever you switch to DC after battery power instead of using wall power. So this little piece right here, I don't know how well you can see it, is the buzzer, the piezoelectric buzzer, which is right here. It's my major noise source. So the first thing I'm going to try is just covering up in tape and see if I can make it not loud enough so that it's okay. Otherwise, I guess I'm just going to desolder it or just whack it off with a hammer. So it's covered in tape now, and as you can hear it, it's still beeping really loudly, so I'm just going to whack it off. So now I'm in the exact same position. I'm running off battery, as you can see by that red light on the left, and no buzz because the buzzer was pried off. But it doesn't cause any other issues. You don't need the buzzer for anything other than to notify the administrator for the system. So time to put it all in the system, and the next thing I have to do is move all of this stuff over to it. So the top stuff on this rack, this server that with all the blinking lights is the only one that's currently running. Everything else on the front of this rack I don't really care about. It's just a monitor and LCD. But this server has 2 power supplies, so I won't have to shut them down. The router, which is up here, will have to be shut down, so that means I'm going to have to power off my internet for a minute. And the one item which I will also have to shut down temporarily, is the switch. I'm going to try to do it as quickly as possible, but we're going to have to do a few quick power switches. Time for the final power switcheroo. Off camera I also changed a few little things. First thing I did, I rearranged all the wiring on here. So this is now a fuse running on the battery pack, so if anything goes wrong, 30 amp fuse goes, tries not to kill anything expensive, which is good. So next thing I have to do is wire everything up to work correctly. So first thing I'm going to do is, because all my other power is going to be unplugged, and the UPS I can unplug just fine with a ton of load, so I'm not worrying about the UPS. And I should pull the servers out a little bit to make this easier to get to, but there you go. Now I have this IEC cord plugged in. I'm going to unplug one of the power supplies on my main server, and it's going to get plugged into the UPS, and it's powered on just fine. So that means my main server is going to be just fine during this whole change, which is exactly what I want, because it's currently working on compressing and moving some files around. Now moving everything else around. So this guy has 2 power cords running to it, and then I have 1 more power cord running up here to the router. I guess everything's just gonna have to be unplugged and moved. Everything's plugging into the old UPS, which is here. So right now, this old UPS is just gonna get unplugged. Here it is finalized. You can see the system, the UPS is at the bottom running correctly, 2 servers above it doing nothing, and then my main one chugging away. and then some other things. It's pulling power off the batteries just fine right now. I can actually monitor battery voltage very easily right now. This is just for testing. I'm going to remove this. And then I'm using this as a basic timer, so I turn it off when power is most expensive. What I'm going to do in the future is I'm going to replace this little box with a Raspberry Pi that does a few things. First thing it does is it monitors battery voltage, so to make sure it's always running when the battery is almost dead. So that to make sure that I don't completely run out of power and die accidentally, which this cannot do. It'll have another little charger to charge the batteries quicker, because the battery charger built into the UPS isn't fast enough to compensate during the standard. I'd be 6 hours off running off batteries, and I think 17 running on. That should add up. No, 19 running on. It'll sort of have another charger. I'm going to get like a linear 48 volt power supply and run it through a bridge rectifier then to the batteries to charge it a bit faster. Third thing it'll do is it'll control a few relays to turn it on and off. So the power isn't expensive on the weekends, so it won't turn it off on the weekends. So it'll do stuff like that, which is to be a little bit more fancy. Thanks for watching this little UPS video, and subscribe for that update for the Raspberry Pi, and it should be kind of a fun little fancy project once it's finally done.